Today we'll use a spot weld connection to model the fasteners for a splice plate. We'll begin by creating our simulation models. We'll also create a linear static solution. Now we'll begin in the Idealize part, getting an associative copy of our geometry. Now that we have that, we'll place some points where we want our fasteners. This will be used later for creating our spot weld connection. Now that we've created points at our 4 holes, we can remove the holes using the Idealize command. Now that we've removed the holes, we can create our mid-surfaces. And then we'll bring those mid-surfaces into our FEM to mesh. I'm also going to select that we want to bring in the points, and a little bit later we'll create some lines as well. Now we'll create a shell mesh on our mid-surfaces. And now we can model our fasteners using the spot weld command. So here we'll select our 4 points that we created earlier and our top and bottom faces. Next we'll select a mesh density value, which corresponds to the number of fasteners per point, which is 1. And then we'll update our mesh, and we'll see that we get hard points driven to the locations of our fasteners, and we also have the C-bush elements that we selected in our spot weld command for modeling the fasteners. Next, we'll check our physical properties for our shell mesh, and we're inheriting the material which was specified on the geometry. And in our mesh associated data, we're inheriting the thickness from our mid-surface. Next, we'll edit the mesh associated data for our C-bush to specify the stiffness coordinate system, and then we'll assign the stiffness to our C-bush. And here I'm using Control-C to copy and then Control-V to paste. Alright, now we've got our physical properties assigned for our connection and our shell mesh, and we're ready to assign our constraints and our loads. We'll go ahead and fix one edge of one of the splice plates, and we'll put a load on the other edge of the other splice plate. And we'll put that in the positive Z direction, and we're ready to solve. Alright, let's take a look at our results. And here we can see our displacement results using 4 fasteners. Now let's say we'd like to use 6 fasteners. Maybe 4 wasn't enough. Let's go back to our Idealize part, and we'll create a line between our points. Now we'll go to the FEM, where we'll edit our spot weld. And instead of using the points, what we'll do is we'll use the curves. And then we can use the mesh density value to specify that we want 3 points or 3 fasteners along that curve. Once we update the mesh, we can see now we have 3 fasteners along each curve. If we'd like to see the impact on the performance, we can go ahead and first clone our solution so we can maintain the original results, and then solve. Now that we have our updated results, we can view our original results, top and bottom, with our new results. And then we can synchronize the views and see how the total deflection has reduced as a result of adding 2 additional fasteners.